Let us see the relationship between pressure and somebody who is flying. For example, a pilot. And also we look at the relationship between pressure and somebody who is diving in water. So what happens when somebody dives in water, and what happens to somebody who is flying an aircraft? So let's look at pressure in relation to diving and aviation. So let's begin with the diving. Now we are saying below the surface of water, pressure is very high. Why do we say so? Because when you are diving, you start from the top of the water going downwards. So as you go downwards, what happens? The height is increasing. You measure height, depth from top going downwards. So the depth will be increasing as the diver moves downwards. So what did we say about pressure and depth? We said the pressure increases with the depth. So when somebody dives and then you keep on descending downwards, pressure also keeps on increasing because the height keeps on increasing. So we are saying below the water surface, pressure is very high. So by the time you reach down below the water surface, pressure is very high. Why? This is because for every 10.3 meters descent means you are descending, you are going downwards. For every 10.3 meters of descent, pressure increases by 1 atmosphere. Another unit for pressure is atmospheres. So pressure will be increasing by 1 atmosphere. Each time you descend, each time you move downwards, each time the diver moves down in the water by a distance of 10.3 meters, pressure will be increasing by 1 atmosphere. So which means down in the water there, pressure is very high. So we are saying high pressures at these low levels cause excess nitrogen to dissolve in the blood. Because down there there's a lot of pressure, it causes nitrogen at these low levels. Then there's excess nitrogen which will dissolve in the blood. And when nitrogen dissolves in the blood, it becomes what? A problem. Especially when now the diver comes on top of the water. You see, when you go down inside the water, the pressure is very high, and therefore there is going to be, at these low levels, there is excess nitrogen which is going to dissolve in the blood. Now when this nitrogen dissolves in the blood, by the time you come up on ascent, when the diver comes on the surface of the water, what happens? As nitrogen dissolves, now nitrogen gas forms the bubbles in the blood. And these bubbles are very painful and fatal. And that condition is what we call the diver's bends. We call that condition diver's bends. Now let us look at what happens to somebody who is flying an aircraft. Aviation, people who are in the aeroplane, what happens to them? At high altitudes, pressure is very low. You see, when the altitude is high, pressure is very low. Thus, aircrafts flying at very high altitudes are pressurized and their openings sealed. So, for those who are flying the aircrafts, especially at high altitudes, you make sure that inside the aircraft is pressurized and all the openings must be sealed. Why? In this way, a normal atmospheric pressure is maintained inside using air pumps. So remember, outside the plane, there's atmospheric pressure. So inside, there is also the pressure due to the air. So the two must balance. So what do we do inside the plane? We make sure that we have air pumps to help us maintain the normal atmospheric pressure so that the pressure inside is the same as the pressure outside. So this is what happens. Now let us look at how the pressure of a gas can be measured. Measurement of gas pressure. The pressure of a gas is measured using an instrument called a manometer. Now the manometer looks like a U. It is a U tube like this. This is a manometer. So let us look at the manometer, which sometimes we call it as a U tube manometer. So a manometer looks like U, that's why it is a U tube. Now inside this manometer, you can easily pour there what? A liquid. The liquid could be water or any other liquid. Now, if you use here water, we could call this a water manometer when there is water. So a manometer, both sides are open. Now when you pour here liquid like water and you leave this side, the two arms of the manometer open, it means atmospheric pressure will be entering from both sides. Because the same atmospheric pressure is pressing the liquid from both sides, it means the levels will be the same. The level at A and the level at B will be the same because the same atmospheric pressure is acting on the surfaces of the liquid at arm A and then arm B. Now, how do you use a manometer to measure gas pressure? In order for you to measure the gas pressure, one side of the manometer, one arm, must be connected to the gas supply. You see? Here we are. Now this side is connected by what we call a rubber tubing. This is a rubber tubing, the one I've shaded here. Now this rubber tubing is the one connecting the manometer and the gas supply. So there is a gas cylinder somewhere there. There is a gas being produced somewhere. So this rubber tubing is connecting the manometer and the gas supply. So that's why we are saying this arrow shows to the gas supply. So there's a connection here to the gas supply. So when you open the tap, what happens? The gas begins moving from the supply, from the container where it is. It comes like this. You see these arrows? It shows that this gas will come with some pressure. And because it comes with the pressure, it is going to press this liquid down from side A. It will no longer be the same like here. In A, the levels are the same because the two sides are open to atmospheric pressure. But here, the gas is now coming from the supply. So that gas comes with the pressure. So it is going to press this liquid down. And as it presses this side A down, what happens to side B? This is side B, the water level rises what? Up. So B is going to be up. You see? So this liquid is going to rise until the pressure at A and pressure at C become what? The same. That's when it will stop rising. Now, this is what we have said about it. Now, as this liquid rises, remember, the liquid was at this height. It rose from here up to here. So, there is that height H. This height H, we always call it the height of the liquid column. Or we could also call it the head of the liquid, depending on the liquid which is there. If it is water, we call it head of water. If it is mercury, head of mercury. If it is alcohol, head of alcohol. So in general, we call it head of the liquid. So atmospheric pressure is pressing here down because this side is open to atmospheric pressure. But this side, it is closed, so it is not open to atmospheric pressure. Now, how do you measure the gas pressure now? There are three pressures now. There is atmospheric pressure. There is a pressure due to the liquid column because this liquid was here. Now it rose like this. So there is also pressure due to the liquid column, which made this thing move from here up to there because there is a difference in height. Then there is a gas pressure. So there are three pressures. So how do we calculate the pressure of the gas? For you to get the pressure of the gas, you simply add these two. You add atmospheric pressure plus the pressure due to the liquid column gives you the gas pressure. So the gas pressure will be equal to atmospheric pressure plus the pressure due to the liquid column, which is H. So this is what I have just said, that a U-tube manometer. We are saying it is a U-tube. A manometer is a U-tube containing water. That is when water is there. If it has mercury, then it contains mercury, depending on the liquid. If both arms of a manometer are open to the atmosphere, the same atmospheric pressure acts on the liquids. It acts on the liquid surfaces A and B, making the water levels the same as shown in the diagram A above. So I already talked about that. If both sides are open to atmospheric pressure, the levels of the liquid will be the same because the same atmospheric pressure is acting on both sides. In order to measure the pressure of a gas, arm A is connected to the gas supply using a rubber tubing as shown in the diagram B above. And that's what I said, that if you want to measure the pressure of the gas, you make sure that one side of the manometer is connected to the gas supply using a rubber tubing. So when the gas tap is turned on, when you open the gas tap, the gas begins moving. So the gas exerts pressure on surface A, making water level at B to rise up until the pressure at C equals to gas pressure. You see? Back to the diagram. When this thing is open to atmospheric pressure on both sides, the level will be the same because the same atmospheric pressure is acting on both surfaces. But when you connect one side to the gas supply, here is open to atmospheric pressure, but here it is not. So the gas begins coming down, and when it comes, it will press this side down, then this side of the liquid will go up. Side A will be pressed down because of the pressure of the gas, but side B will rise up. So this liquid is going to rise until the pressure at A and C are the same. That's what we are saying. So now, how do you calculate the pressure of the gas? Remember, you want to measure the gas pressure. You simply add these pressures equals to this one. The gas pressure equals to atmospheric pressure plus the pressure due to the liquid column. Okay? So this is what we are saying. The pressure of the gas is equal to atmospheric pressure plus pressure due to the liquid column. Now we can put this in the form of an equation using letters. P, that is the pressure of the gas, is equal to H, capital H, that is atmospheric pressure, plus smaller h, that is the pressure due to the liquid column. Now, H means capital atmospheric pressure, smaller h means the head of the liquid, which sometimes we also call it excess pressure above atmospheric pressure. Then rho means the density of the liquid, and g means acceleration due to gravity. So if the atmospheric pressure and the height of the liquid column, they have the same units, maybe this one is in centimeters of mercury, this one is also in centimeters of mercury, you just add and you will get the pressure of the gas in centimeters of mercury. If this one is in millimeters of mercury, this one is also in millimeters of mercury, you can add and you get your answer also in millimeters of mercury. What about if the units are not the same? This one is different from this one. What do you do? Supposing this one, atmospheric pressure is in SI units, which is in newtons per meter squared. The SI unit of pressure is in newtons per meters squared. So if this one is in newtons per meter squared, and this one is maybe in millimeters or centimeters of mercury, there is no way you can add the two because the unit is here and these ones are different. So what do? You make sure that all of them are in the same units before you add them. So if this one is in newtons per meter squared, sometime back we talked about how to change centimeters of mercury, millimeters of mercury into newtons per meter squared, and we said you are supposed to use the formula H rho G, and this H becomes the height of this one, the height of the liquid, but now it must be in SI unit. This one is in newtons per meter squared, so the height should also be in what? Meters. The density should also be in SI unit. Acceleration due to gravity should also be in SI unit. So in brief, we are saying if these two are the same, you just add. But if the units are not the same, you have to convert this one into these units. And how do you convert? By writing H rho G. H will be the same height here, but should be in meters. This one is the density of the liquid, depending on the liquid which you are using, whether mercury, whether alcohol, the density. Then G represents acceleration due to gravity. Okay, now we are saying we should note that the excess pressure, whenever somebody asks you excess pressure, that what is the excess pressure of the gas above atmospheric pressure, that person is asking you for the pressure of the liquid column. That person is asking you for the pressure of the liquid column, BC, according to the other diagram we had. So where do we use manometers? There is a machine which is called a sphygmo manometer. You see, as you can see, the word manometer is there. It is called sphygmo manometer. This machine is used by doctors to measure the pressure of patients' blood pressure. So manometers are used in that instrument. Now let's look at some questions related to manometers. Examples. Study the diagram below. You see, so this is connected to the gas supply. So when the gas comes, it presses this part down, this part goes up. So from here up to here is a distance of 15 what? Centimeters. So the smaller h is 15 centimeters. Okay, so the first question here is find the excess pressure above the atmospheric pressure. You see, and I told you that the excess pressure is the same as the pressure due to the liquid column. So you could just say, remember the examiner wants the answer in centimeters of mercury. And these are also centimeters. So you just put this as the answer. You say, my solution here, Roman 1, excess pressure in terms of centimeters of mercury is the same as the pressure due to the liquid column. And what is the pressure due to the liquid column? It is from here up to here. The liquid rose by 15 centimeters. That is the pressure. So you simply write here, which is equal to 15 centimeters of mercury. Remember, he wants the answer in centimeters of mercury. And the height is also in centimeters of mercury. So you just tell him or her that the excess pressure you want in centimeters of mercury is the same as getting the pressure due to the liquid column. And looking at the height, it is also in centimeters. So this is 15 centimeters of mercury. So if there are 2 marks, the first one will go here, saying excess pressure is the same as pressure due to the liquid column. Looks to be a formula. Then the answer is 15 centimeters, and the unit is centimeters of what? Actually, the answer is 15, then the unit is centimeters of mercury. So you get all your marks. The examiner still asks the same question, but in different units. He still wants you to calculate the excess pressure, not in centimeters of mercury, but in newtons per meter square. That means, remember, newtons per meter square is the SI unit of pressure. So how do you change centimeters of mercury into newtons per meter squared? You use the formula for pressure in liquids, H rho G. The height was 15 centimeters. Change the centimeters to meters, divide by 100. Times the density of mercury. The examiner has not given you. He knows that you are aware. Depending on the liquid which is there. Which liquid is there? You see, the liquid is mercury. So you use the density of mercury. If it is water, you use the density of water. If it is alcohol, you use the density of what? Times acceleration due to gravity, which is 10. But make sure that this density is in SI units. There are 2 units of density, grams per centimeter cubed, which is not the SI unit of density, and then kilograms per meters cubed. So you use SI units. The density of mercury is 13,600 kilograms per meters cubed, times acceleration due to gravity, which is 10. So when you do this calculation, you end up with this. Your answer will now be, in what examiner wants, newtons per meter squared, which is the same as what? Pascals. So how many marks were given here? How many marks? There are 2 marks. So could you give formula half, substitution a half, correct answer half, correct unit half. Let's look at the second one. Calculate the pressure of the gas if the atmospheric pressure is 76 centimeters of mercury. You see? Calculate the pressure. This is a part B of the same question. So we are still talking about this diagram. We are still talking about that diagram. So, what did we say? That the pressure of a gas is the same as atmospheric pressure plus the pressure due to the liquid what? Column. P, which is the pressure of the gas, is equal to H, capital, that is atmospheric pressure, plus pressure due to the liquid column. If the units are the same, then you just add. Here, the atmospheric pressure is in centimeters of mercury. What about smaller h? Smaller h is also in centimeters, so you just add.